What we want to do in this particular problem is take the graph of y equals f of x, which is shown, and obtain the graph of q of x equals 1/2 f of x. As we look at what we're trying to graph, we should recognize that f represents the output of the function. So we're essentially taking all the outputs, or the y coordinates on the graph of y equals f of x, and multiplying them by 1/2. So to obtain the graph of q, no longer is -4 comma -2 on the graph, rather it's -4 comma -1. Instead of 0, 2 being on the graph, it's going to be 0, 1. Continuing in this fashion, we obtain the graph of q of x. Notice that all the y coordinates are exactly 1/2 the values that they are in the function y equals f of x. Now, let's go ahead and graph h of x equals f of 2x. The difference in this problem is that we're taking the x coordinates and multiplying them by 2. To obtain the graph of h from the graph of f, what we have to do is in fact take all the x coordinates on the graph of f and multiply them by 1/2. The logic behind this is the following. F represents the output. What we're doing here is doubling all the inputs. So let's say that for some y coordinate you had an input of 2 on f. So in other words, f of 2 gave us some y coordinate. Well, to get the same y coordinate on h would require that x be half of that, or only 1. That's the reason that we take the x coordinates on the graph of f and multiply them by 1/, the coefficient of x, in this case 1/2. So instead of -4 comma -2 being on the graph, it's going to be -2 comma -2. 0, 2 remains on the graph because 1/2 times 0 is 0. Instead of 2, 2 being on the graph, it's going to be 1 comma 2. And instead of 4, 0 being on the graph, it's going to be 2 comma 0. And here is the graph of y equals h of x.